So we want to find the value of this equation. Best way to do that is to turn it into two separate equations and add them together at the end. So we have this first part, it's very simple, it's just equals that. This second part of e to the 3 over z, so we know it's e to the w is this series, so we just replace e to the w with e to the 3 over z, which will give us this series here. We then multiply these two parts together, which will then give us this series here. We know that there is an essential singularity at z equals 0. So if z equals 0, it's undefined. And we know that there's no simple pole here, that is, z isn't raised to the power 1, therefore all these terms will equal 0. That way the residual of this function, which we'll call h of x, the residual of h at the point 0 equals 0. That's a 0. So further on, we just move on to the next part. So we know that there's the essential singularity, so there's a singularity at the point 0 and at the point pi and 4. So to find the value of this, with the residual theorem, we have it's 2 pi plus the two residuals, multiplied by the two residuals. So to find the residuals, we have this formula and we just apply it. So we have m for this first bit is 2, for the second bit it'll be 1. So m minus 1, so 2 minus 1 is 1, so it's 1 over 1 factorial, first derivative of z squared cos z, z squared, z minus pi on 4. Those two terms will cancel, and then it's just the quotient rule, which is z minus pi on 4, pi on 4. So the first derivative of cos is negative sine z minus cos z, z minus pi on 4, all over z minus pi on 4 squared. So then we just substitute the 0 into this equation, which will give us negative pi on 4 multiplied, so sine to the 0, sine 0 is 0, minus cos of 0 is 1, negative pi on 4, all over negative pi on 4 squared, which will then equal 4 on pi. So for the other singularity, we have m equals 1, so 1 minus 1 is 0, so it's over 1 over 0 factorial. Because it's 1 minus 1 at 0, so you don't take the first derivative at all, it's just the function. So it's z minus pi on 4, and it is cos z, z squared, z minus pi on 4. Those two terms will cancel. Factorial of 0 is 1, so it's just the limit of z approaches pi on 4 of cos z over z squared. So we just substitute pi and 4 onto this equation, and we end up with 8 root 2 on pi squared. So then for the entire answer, we're just going once round, so it's this term and this term, that's 0 up here, so it won't make any difference, so we can just ignore it. So it'll be 2 pi I times 4 over pi plus 8 root 2 over pi squared, which equals 8 2 root 2 I over pi. So this is traversed once. So if we're traversing it 3 times, we just multiply this answer by 3, which gives us 24 pi plus 2 root 2 all over pi.